This is an equilateral triangle, which means all three sides are the same length, because that's what equilateral means. And it says, right, the area of an equilateral triangle is a function of the side length S. So if this is S, so, all right, how do you find area of a triangle, first of all? Okay. If this is S, right, I drop down an altitude here at 90 degrees to find the height. Yes? Are you all okay there? This is still S. But I need, then it is, what kind of right triangle? A special. It's a 30, 60, 90. This is S. This would be what? Half of S. Right? If I have, how do I get to here? All right, how does a 30, 69 triangle work? Let's ask that. 30, 60. Or hypotenuse is 2x. Right? But this time I'm going backwards. So I'm going from the short leg. Sorry. Yeah. I've got the short leg. So how do I go from the short leg to the long leg? Well, I've already divided by 2. You divide the hypotenuse by 2, right? So I take the short leg and multiply by 1 to get the long leg. Y'all, look at this triangle.
Why do they look different?
Okay, and what is X?
S. Square root 3 of S.
Okay, but it's already S because I know that. This is.
Square root 3.
It
Square
says.
root 1.5.
Oh my goodness.
Oh my gosh, tell me that.
All right. Listen. Okay. What? I'm just shouting random things and I don't even know what's going on. All right. Don't think about the X's and the S's and things like that in the way that you're thinking about them. The problem itself defined the side length as being S. Okay. So in other words, I'm starting at the hypotenuse and then I'm going to the other legs.
Wait a minute. In your diagram,
yeah, the bottom.
See, that's what I'm saying.
Should be square root 3x. It's like that bottom return on stuff.
Oh, the way it's, yeah, this is actually should be like. The shortest side is across from the smallest angle.
So in the original problem, the bottom.
So this is the long leg. It's across from the right. Across from the smallest angle is the smallest side. Think about like a hinge.
We're confused because that's correct. 30 is the smallest.
But the side lengths did not correspond. Yeah.
So
it should look like.
Like, why would we throw 1/2 in?
And I could be even a little bit better.
How do you know? Oh, wait.
Shouldn't the 60 and 30 be flipped on the bottom triangle on the left?
Yeah.
There you go.
Okay. All right.
X, 2x, it's still the same though.
On the bottom left
Figures not drawn to scale. Okay.
on the bottom
Yeah.
left triangle, shouldn't the 60 and 30 be flipped?
No. Because, are you talking about based on my equilateral triangle or based on a 30-69 triangle? It's not to scale, yeah. So look at the purple triangle. Okay.
Alright, so.
Always working from the short leg to get to the other things, but if you don't have the short leg, you can also go backwards to get to it, right? So if I start with the hypotenuse, to get from the hypotenuse to the short leg, I would divide by 2. Do you agree?
I would think so.
I'm given the hypotenuse because it's S. So to get to the short leg, I divide by 2. That's where I get 1/2 S. Yes?
Would it be like 1/2 S times?
Yes. Yes. So now I take the short leg and I multiply by the square root of 3. So take this short leg and multiply by the square root of 3. So it's actually square root of 3 over 2 S. The 1/2 S, right? So now my height is actually square root of 3 over 2 S.
Would that become S squared?
Yes.
So.
All right, so remember, it wanted me to write area in, what did it say? Area as a function of side length.
So it'll be side length, so it'll be
Square root of 3 over 4 S squared.
Wait, what did it want you to write?
The area of an equilateral triangle as a function of its side length S. That definitely, 30, 60, 90, 45, 45, 90 triangles come up all the time. So I'm going to say yes. All right.
Let's do P.
Part B says find the instantaneous rate of change, which just means what?
Derivative.
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 So if the area is root 3 over 4 S squared, then dA ds is, okay, so 2 times that would be the square root of 3 over 2 S. Okay, wait, y'all. Yeah. 2, 2, right, and 2 divided by 4 is 1/2. Yes, we are. 2 square root of 3 over 4, but I can simplify 2 over 4. Okay? I did not kill a kitten, Dylan. Only when there's adding and subtracting in there can you kill a kitten. What does that mean? Part C, evaluate the rate of change.
Wait, no, we didn't do part B.
Yeah, we did.
With respect to the certain.
We're on number 3.
Now it says with respect to the side X.
That's why we did DADS. Evaluate the rate of change of A at S equals 2.
Well, then we can plug in.
So we just plug in. So dA ds when S equals 2 would be the square root of 3 over 2 times 2.
It'd be square root of 3. Yeah, I got that.
How about the rate of change when S is 10?
But then it'll become like some stupid. I have to put my calculator.
There we go. What about when it's 143?
What's 10 divided by 2?
Oh yeah, but like.
Put the 10 over 1, you just plug in, and then you cancel the 2, make it 1, cancel the 10, make it 5. Are you understanding that? Let me show you.
No, I got it. I thought about it. I got it. I don't need your help.
Okay. Part D. If S is measured in inches and area is inches, inches squared, what units would be appropriate for dA ds?
Actually, no, it was mine.
That's exactly right. It's inches squared over inches, or inches squared per inch. The area increases at a rate of da 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 inches squared per inch.
And what you would do is you would find, and then you would do all of that. You would probably end up going somewhere like McDonald's or something.
And then you would go and you would find the biggest
and jump off.
Wyatt drops rocks off of the cliffs. He doesn't jump off of the cliffs. Then he measures the instantaneous speed.
He made a miscalculation and he falls.
Number 4. Which Alright, so a square of side length S. What is what, Katie? I'm sorry. Last night. Oh, what is it called? I'm sorry. Did I not put it on there? I swear I did. Are you sure?
Well, you told us at the end of class.
Particle motion. Well, yeah, that's the name of the lesson. We haven't gotten there yet. This was the intro to it. All right, a square of side length S is inscribed, I lost my place, in a circle of radius R. I know. Write the area of the square as a function of the radius R. Oh my goodness. What are we going to do? Well, since it's inscribed, if I can find the length of this is, 2 of these will make up S. This one is a half of S. It is. It's a 45, 45, 90 triangle because I've split this angle here because we're thinking about properties of inscribed squares. All right, so this is 45, so I've got this 1/2 S. These have to be the same, right?
And then that other one's probably like.
All right, so to get from a leg to the hypotenuse, I do what? Multiply by square root of 2. So if I multiply this by square root of 2, I end up with square root of 2 over 2 S.
How do you know that you have to multiply by square root?
Well, because square root of 2x is like for the hypotenuse of 40, 45, 90.
How do we memorize it?
Bless you.
Wait, is
Will
it
you give
always?
us practice problems like this?
But wait, this is not what it asked. This is not what it asked. We have to write it in terms of the radius. So instead of doing this, I need to do, if this is R, do you agree with that?
No, I don't.
It's a 45, 45, 90 triangle.
Alright, so what are the numbers you use?
Well, I have to write this. I've got to figure out how to write the area of the square.
I know.
And
What are they usually?
what are what?
What are they usually?
What do you mean what they use? Yeah, I'm sorry.
Divided by.
That's using the R, this is using the S. I've got to figure out how to write. I need to figure out how to write this with only R's. So what am I going to do?
R over square root of
I need to know what S equals is what essentially.
You need to find out what that side length is and multiply it by
What's
that.
that? Yes. Yes. But I need to know I need to write this in terms of with using R's.
Yeah, so you just get the side length and multiply it by 2.
What up, my dude?
Right? Half the length.
That would make sense to me.
Close. If square root of 2 over 2s equals R, then what does s equal?
2 over square root of 2 R. But you have to
Rationalize it.
Square root of 2. It would be square root of 2.
Wait, how did you just like?
Excuse me.
I multiplied by the reciprocal.
Where did 2 go?
Wait, you're what? Oh, how did I get from here to here? So if s is the square root of r, the square root of 2r, what's the area of the square?
The square root of 2 times the square root of 2.
Say that again.
Oh, the area?
The area of the square.
Well, one side is going to be double that, and then the area.
Is it double? It's not double.
It is double. Yeah, the triangle covers half the side.
Well, the area of the square.
There's just side.
No, because you found
I found s instead of 1/2 s.
Yeah, it's
Yes. Which is, since it's a square, that's the hardest part of these. It's finding that formula in time. And we will be doing this whenever we get to some other things
Wait,
too.
did that last time give me area?
Okay, so I found out what s is. That's not the side, that's literally the s. The s is the side length of the square. So if s is square root of 2r, then that means this side is square root of 2r, which means to find the area, I multiply the two sides together.
Yeah.
So you was.
A square.
Well, I know the square, but like, or wait, no.
Yeah. That's okay. Do y'all need me to do the rest, or y'all okay there? Because the rest is kind of downhill from there. What's IROC? What's DADR? 4R. What's the rate of change at 1? Yeah. Well, the squared goes to both of these. And then evaluate. Evaluate when R is 1, 4. When R is 8, 32. And then what units, if, again, we're in inches and inches squared. Inches squared per inch. Y'all need a brain break? Well, we did 2 of the 4 you had for homework, so yeah. All right. Particle motion. Particle motion. Guaranteed FRQ. Yeah, I've never seen it not incorporated into an FRQ somewhere. What, triangle problems?
I like did not do that. Whenever all of them have like 100 of them, I got like a 9. I did not. Like almost my first.
So I would say the biggest thing about geometry to remember, special right triangles for sure. Commit those to memory. Be able to work them forwards, backwards, left, and right.
There's not like a properties. That's how you do it.
Hmm?
You know, like properties, like the opposite angle.
Yeah. Yeah, no, you won't see that too terribly often. Particle motion. What's happening here? Did y'all take physics?
Yeah. But like, oh, no. It was
I took AP
the
Chem.
only thing I
We
learned.
tried to take AP.
Like they have like.
Thank you.
Particle motion. So we are talking about distance that we are going to call S along a line. S is the absolute, like if you see S of t, you know you're talking about position all the time. Along a line from some point of origin. This is like the definition. And so we use S of t to describe the position of the particle along this line. I always envision this little bug walking, I don't know why. I think my calculus teacher must have used this as a visual at some point because it's ingrained in my brain. But I think of some kind, like a little bug walking along a ruler. Back and forth is my particle along a line. I don't know why. I don't know. That's just what I see when I think about particle motion. But we're talking about the distance that it travels along a straight line from some point of origin.
What you're saying is that this thing.
Well, that would be my time, but we're talking about position. So this function will tell us where he is after 4 seconds. Or where he is after. We're going to use IROC here. We'll see. Do what? So as I reference this, as we go through, I think the easiest thing to do is to use an example to go through to show you. So this is number 19 from your homework, that as I show you each definition, I'll show you each part, because 19 is an A through F question. And so number 19 says a particle moves along a line so that its position at any time when t is greater than or equal to 0, because obviously I'm not talking about negative time, right? I'm not going backwards in time. Along is given by the function blah. So you know that its position because it's S of t.
What else? I thought it was chilly. I am just burning up over here.
And then it says that S is measured in meters. There's an ant on my tablet. And yeah, it's the, yeah, come here and do particle motion with us. S is in meters and T is in seconds for this particular problem, number 9. And so the first thing it says is find the displacement. Ooh, I'm glad you asked, man. Did you really?
I'll take AP Chem though.
Exactly. If you think about, you could have, maybe even in physical science, you learned it. Whenever you like drop an object in water and how much water is displaced is the change. So really what displacement is your change in position. Or delta S, right? Change in S.
It is so hot. Yeah, it is. I'm about to die. Why is that fan not going yet?
You take where you end up. T is the time you started, and you add how much time you went, right? So you have to take that into account because maybe I'm not looking at displacement during the first 5 seconds. Maybe I'm looking at displacement between seconds 20 and 25, right? And then I'm going to subtract my initial position. So this is, because I'm trying to make this really complicated right now. I'm just kidding. But right. Yes.
That looks like difference question.
It's like the top of that.
It's funny you say that because just wait. This is part A of the problem, remember. So, and this is the reason that I'm showing it to you this way too, so that you see. But it is just the difference that it changed. So what is the displacement during the first 5 seconds? You tell me.
Plug in 5 for T, right? Now, what do we plug in 5? What is it?
Well, your initial is 0, right?
So my final time,
you don't even need that.
I started at 0 seconds, right? 0 plus my change in time was 5. And then my initial was 0. If I started, right, if I said, what's the displacement between t equals 20 and t equals 30?
Are you serious? You had to talk back.
Then you would have to plug in 20 plus 10, which would be my 30. Up to minus 4. It's a complicated way to write it, but there's a reason I'm writing it that way. Because what we're going to do whenever it's going to leave it. Dylan's right. It's going to start looking like a different question.
Dylan's middle name is actually.
All right. So what do you get? Tell me the answer.
What is it's 5 times S.
S of 5 is 5 squared minus 3 times 5 plus 2.
Oh, 2. They gave us.
Yeah. 25 minus 15 plus 2, which is 12. 12 what? Meters. This is just distance. This is just, S is just meters. And then S of 0 would be 2 meters. So what is the displacement? 10 meters. Displacement. Remember, I'm looking at the change in position, how it changed. So my final position was at 12. In this case, I started at 0 on my ruler, right? And after 5 seconds, how far have I? Actually, I didn't start at 0. I'm sorry. Where did I start on my ruler? At 2. Right? I know that here because at 0 seconds, I was at 2 meters. So if I'm on this ruler 1, 2.
So you plug in 0 because you just have to, you gotta find that out, I guess.
In 5 seconds, that's how far I made it, and here's where I ended up. Oh, no, I lied. Gosh dog it.
No, it's
12.
So after you plug in like the first one, do you always plug in the initial value also? Like you did?
Yes.
Alright.
Sorry. Don't overcomplicate this. This one's easy. Position's easy.
This is like probably like at least 6 of these problems. So you just use the tip of the difference quotient.
I have problems with the keys.
You just use the top of the difference quotient.
You just do the change in position from 0 to 5. Okay, yes.
Well, you just do it.
Part B says, find the average. I'm emphasizing that word because that's A, right? Find the average, wait now, velocity during the first 5 seconds. What unit is velocity in? this case, it would be
Meters.
meters
Per second.
per second. Meters per second. If I want average velocity,
It says that velocity is in meters per second.
if I want average velocity, I'm going to do a rock of position. That gives me my average rate of change, exactly.
So, did you start making the honors class read their book because you're an ad?
They don't have to read their book.
Yeah. The other day, I remember we were like, read quietly.
Oh, that's SSR.
Second one, right? Yeah, so that is read.
Now, here's where units are going to be crucial. Okay, so make sure you include units. You will lose your whole answer point for not putting your units in there. All right, so average velocity would be difference of the y's, which is my position, 12 minus 2 over difference in time. All right, we have done this before when we talked about position and things and average rate of change when the rock was dropping over certain time periods, right? Right.
Wait, so that's the answer?
That's the answer.
Oh, so A-Rock's the same way.
Average velocity. Look, I'm going through each of these because particle motion is just really a bunch of formulas you're doing. No. All right, so displacement, change in position. Average velocity is a rock.
If this is pretty much different question, why couldn't we just do?
That derivative is not average. What is derivative?
I'm saying for the first part of that.
Well, because it was asking me, it wasn't asking me for any rate of change of the function. It was, right. Now listen to this one though, Van. Find the,
I hate that word. Actually, I like that.
So, I-Rock of SO4.
so here, this is key, highlight this, whatever it is you need to do. The derivative of position gives me velocity because I'm talking about I-Rock. That makes sense, right? I-Rock, instantaneous rate of change is derivative. So if I do the instantaneous rate of change of the position,
So,
it will
Jen,
give me
would you
the
just plug
instantaneous.
4 into that equation and then get the derivative?
Get the derivative and then plug in 4.
I see.
Okay, so I want to do
So it's going to be 2t.
S prime of t, which is v of t.
Did you give us a second?
Oh, I was supposed to be writing this in pink. So it's 2t minus 3. So are we all in agreement that velocity
It's the derivative of that first equation. It was t squared minus 3t.
Okay, that makes sense.
Okay, so then plug in 4 to that and you get like 8.
do what? The shortcut?
I love power rules. It's so
It's my favorite thing ever.
So what is the instantaneous rate of change at 4 seconds? And you're exactly right. The units are crucial here. Do not, if you just put 5, you've lost your answer. It's meters per second.
It's always meters per second.
In this one, because that's how it was defined to start with. It said S is in meters and T is in seconds. Ooh, how do you do acceleration? I love particle motion.
We're on D, right?
But we're on C. Oh, we're on D. D is acceleration when T equals 4. What is acceleration?
Well, that's when you start to go fast.
This is if you'd had physics also, this would probably make a little more sense. I'll just tell you. Acceleration is the instantaneous rate of change of velocity. So it's the second derivative. So acceleration is the derivative of velocity, which is the second derivative of position. So just to what? 2, not meters per second, meters per second. Because it's acceleration, I'm dividing again. It's the rate of a rate. Bless you.
You go like back through that again.
Yeah, you're gonna have to.
I'm gonna have to write down. So
Okay, acceleration is the derivative of velocity. Average velocity, yes, but instantaneous velocity, which is what you'll do more often than not.
Instead of acceleration, you're thinking.
Right.
Okay, so you find the derivative of the velocity.
Mm-hmm.
So you're finding the derivative of 2t minus 3?
Yes. So just to kind of sum this up over here, position here was t squared minus 3t plus 2.
Yes.
Velocity then is 2t minus 3. And acceleration is just 2. My acceleration is constant.
Wait, what was the first S of t?
Position.
Alright.
Okay. All right. Don't forget your units. Okay.
Why is it squared?
Because it's the rate of a rate. Ooh, we're going to talk about it. You have 5.
Yeah, but they have so many points.
And 19 is one of them.
So like we need at least like 7.
19 through 24 is your homework tonight.
19 to 24.
But we're doing 19 together. You have.
All the parts, a lot of them.
So can we just finish 19 and start ourselves?
Yes, that's the plan.
Like,
Part E, we got 2 more parts. Y'all. Dean doesn't fix AC, he does computers.
The man with the beard.
Jeff? That's his name. With the goatee?
Yeah.
Older man? Yeah, I love Jeff. He's super nice. He would. I used to always call him to come fix my AC because I was always hot, and he said I was a diva and had to have it cooled in my room.
He said he always would say you're hot.
No, I would always call him and say, I'm hot, can you please come fix my air conditioner? And he said, no. That was a diva. All right, part E. We got 2 more parts. At what values, this is the part where you have to think. At what values, put your thinking cap on. You have to think back to algebra here. Of t, does the particle change direction? Ooh. Because remember, my bug could start walking this way and then change and go that way and then change and go this way. It does have to do with the graph. Okay, first of all, which graph should I look at? The derivative is velocity. So am I looking at the velocity?
Well, you can look at the velocity change. Right? Or you can look at the acceleration. Yes.
Because negative acceleration is like, no, not negative, but like.
Well, it can't be acceleration.
But when
I've got a constant acceleration here. And this one does change. It's what?
It's a displacement, change in position. gotta be it. I didn't hear that.
Thank you, Van. Let me give you a hint.
So actually, it'll be is these over both of them, and then
Which function is that?
why did you draw
The original.
The original.
Hey, look at the word look.
Now, think of what my S of t looked like, right? It was. All right, listen. What happens? Think about this, the graph of this position. That's a straight parabola. You're exactly right. Where does a parabola change direction?
At the minimum or maximum.
So, now wait. If we know direction changes, we set a vertex here, but we actually, depending on what it is, at any max or min is where direction changes, yes? I don't want to have to graph this and calculate maxes and mins. What can I do? Think calculus-wise. Yes. Somebody get it, please. Somebody. Derivative what? What? So what should I do? Close. Set the derivative equal to 0. Where is the derivative 0? Where does it have a horizontal tangent? Y'all have done that.
Oh, wow, that is actually way easier now that. So,
what is the derivative of position? Velocity. So where does the particle change direction? Well, I need to do velocity equal to 0 and solve. Do you understand why? Because that's where my minimum of my parabola is occurring, because there's a horizontal tangent. So if I take the derivative, set it equal to 0 and solve, I found my horizontal tangent, so I found my max or mins.
Do you know which formula to use for the derivative?
You start with position and do the derivative of position.
So,
and I've already done that, right? What? That's it. Make sure you use the right units. When does it change direction? It changes. Imagine if you were in pre-cal or algebra 2 and you had to find the maxes and mins of the function and you didn't have a calculator. You could just find the derivative and set it equal to 0 and you'd find every place where it changed directions. Isn't that cool?
Why didn't we learn derivatives earlier?
I agree. Aren't they cool though? And they're cool.
I don't like the difference question. That one.
The very last.
Taking up the whole page.
This is the last one.
Am I gonna have 7 pages of homework?
No, it's because I'm doing your notes with this problem. Where is?
No, it's still in there.
Where is the particle when S is a minimum? But if it's 3/2, where is it? So now I'm not talking about when is it, I'm talking about where is it. So I need to plug it into which formula for T? If I'm talking about where, into the position, the original. So I'm looking for S of 3/2.
They all like go off of each other.
Okay, Blue. You're funny, Blue.
Alright.
What'd you get?
Wait, what are you? So you said that.
Wait,
What does that mean? Is it what?
is that
Not displacement, that's where it is when it finishes
Wait,
moving.
where am I plugging this in though?
So think about this. He's moving along this ruler, right? He starts at, what did we say? He starts at 2, and he moves, but then he changes direction. Where does he end up at the end of 5 seconds? He ends up at the end of,
Wait, which
or
equation?
this is at the I'm sorry, this is at the minimum.
Which equation am I plugging in?
S, the position.
Oh yeah, I know which one.
T squared minus 3t plus 2.
Oh,
The original.